We're just going to start off with what is it that you believe? How long have you believed it? Why? And what's your explanation for why that is? And then we'll kind of let you guys take it
All
from
right.
there.
Yeah. Well, I used to believe in the globe, and then I believed in the globe most of my life, like every flat earther. And then I lost that belief, which is all flat Earth is. It's not actually like a belief system like the globe. So
Okay. How long has it been since you've stopped believing the globe, I
the
guess?
globe,
Yeah.
probably like 4 years, I think.
Okay. Why is it that you stopped believing in the globe, I guess?
Um. Well, I mean, we're just gonna get into that right now, I guess.
Okay.
Yeah.
That works for me.
Okay. Yeah. Okay. Good.
So, yes, hello, I'm Kat. Thank you for contacting me again. This round 2 was very unexpected, but I'm here for it. Last time I spoke to you, you had a certain set of beliefs. I guess for me, mine have not changed. I still believe that the globe is spherical, non-hollow, there are things in the middle, etc. Physics still works the way I believed it as last time. I believe that the Earth was a spherical, non-hollow globe, probably since I was still inside my mom's ovarian section. I guess, why currently, from the last time I heard from you, you believed that the Earth was flat because you thought that there was a certain
Right.
set of people
Well,
that were
it's
trying
not
to propagate.
no.
Yeah.
No. It's not it's not a belief, since flat Earth is all you experience. So it's not like a belief system. It's just self-evident.
Well,
You know,
I didn't
like
say
you
that
don't
it
actually
was your religion,
experience.
right? It's
Well,
something that
yeah.
you think is true, thus you believe it. Think and believe are synonyms of each other. So you would
Okay, but um, I don't really believe it's true. I just experience it. So, I mean, if you say you have to believe what you experience, then okay, but you don't experience the globe, but you do experience flat stationary Earth. So,
Okay. I mean, if you're inside of a car, and the car is
right.
not
Well,
going at a consistent speed, it feels stationary to you, but relative
right.
to the
We can
ground,
do
it's
that in a
not.
second.
Okay.
Yeah, let's go there in a second. But are you aware of the Guinness World Record for long distance photography?
Nope, the Guinness World Record is not something I just look at.
Yeah. Um. Well, the world record is somebody took a photograph of mountains 275 miles away, and these mountains would be 9 miles down behind the curve of the Earth, and the tops of them would be 3 miles behind the curve of the Earth. Yet you could just see them in a photograph. And this isn't the only long distance observation that basically debunks the claimed geometry of this globe. There's tons, literally tons, hundreds, but that's just the world record.
Okay, so
So
from the
yeah, that
last
pretty
time
much.
you and I had
Yeah.
spoken about this, I had also said that the rate at which you believe that it would dip was not actually the rate at which the curvature would dip. It was only something like every 100 kilometers you get roughly 0.1 degree of an angle of dip, from my last calculations. I might be slightly off, but it was something around that. So that still wouldn't be enough for you to notice a sizable dip if the mountains are
Well,
275 miles away.
right. But it still would be 9 miles down, around like a physical obstruction. So.
But
Yeah.
0.1 degrees when you're looking at mountains, how high up are the mountains?
It's like 12,000 feet.
Okay, so yeah, that's not the amount of like curvature that we would end up seeing for something like that. But let's back up a
Well,
little bit.
it's
Where
50.
are you getting
It,
these
it's
numbers from?
50,000 feet of drop.
Where are you getting
It's
these numbers from?
the claimed geometry of the globe, the radius measurement.
Okay, and
Which
are you personally doing these calculations, or
yeah. Or I mean, you could look up Earth curvature calculators, or you could just do it yourself.
Okay. Just so that I can know that you're not just pulling it out of thin air, are you able to send me one of these websites that you're referring to in our group chat?
Yeah. What which
the one that we have all three of us.
Oh, right. Okay. It's just I just sent it. Yeah, it's basically 8 inches per mile squared. So you just take the amount of miles and then just square it and then multiply that by 8, and that's the amount of inches. So like for 275 miles, you just do 275 squared and then multiply that by 8, and then that's the amount of inches. And then you would just divide it by like 12 to get feet. It's about 50,000 feet of drop for 275 miles. And we'll get into this probably in a little bit.
50,000 feet of drop for 275 miles.
Right. And we'll get into that into this in probably a little bit, but this whole entire rate of curvature isn't actually based on anything. So like the Earth was actually never measured as a ball, anyways. So this is all like.
Sorry, what do you mean it's not based off of anything?
Well, this claimed geometry, like for 100 miles, it's 6,000 feet of curvature. Like that curvature rate, like 5 miles is like 16 feet.
For 1,000 miles, it's 6,000 feet of curvature.
No, 100 miles. So this whole curvature rate is based on the radius.
Like what?
Like drop, like 6,000, 100 miles would be 6,000 feet down, almost 7,000 feet actually. But this is all based off the radius measurement.
Okay.
Which, when you look into how the Earth was actually measured as a ball initially, which is the radius measurement, they didn't actually measure the Earth as a ball.
So what did they measure it as?
Well, they didn't measure anything really. They just asserted that the Earth was a ball based on assumption. Like if you there was two methods, Al-Biruni and Eratosthenes.
Currently no one believes, like at least scientists, if you need to have precise measurements, no one thinks it's a perfect ball, right?
Yeah. They say oblate spheroid.
Yes,
even though the pictures of Earth from space depict a perfect sphere.
Yeah, because
because it's fake, right?
No, it's squashed to an extent that it's not noticeable for the human eye. I think it's like in the X direction and the Y direction, they're both equidistant from the center, but from the Z direction, it's something in between 90% to 100% the amount of the X and Y direction. So it's slightly smushed, but not to the extent that like your eye would see, but it would be to the extent that you would need to calculate for if you're doing something like having a satellite that needs to orbit and you're leaving from a certain direction. So that's where those types of things come in, but the human eye is not particularly known for being the most accurate type of machinery. The human eye is nice and all, but it's quite fallible. So thus why we have other types of instrumentation for these things.
Sure. But the pictures from Earth, from space, are done by an artist, Rob Simmons. And he says, it's on I could link you the NASA website showing it, but he says that they took a flat map and wrapped it around a ball. And then he like touched it up and did like CGI basically. Like it's a CGI composite, and then he like photoshopped a bunch of stuff to like make it look different.
You know
And
that
what he
flat
said,
maps show that the continents are a size that they actually aren't. So if someone were to just get a flat map and wrap it around a ball, Greenland would be very inaccurate to its real size, and that's not
right? That's
what
why the
we get.
continents are actually very inaccurate in the ball Earth pictures. Like there's ones where one continent is like taking up the entire ball Earth, and there wouldn't even be enough room for all the rest of the continents. But Rob Simmons even said he didn't know that his image was going to be such a big deal until he bought an iPhone and turned it on and saw his image as like the default background.
Can you please send us?
Yeah, let me. But basically, what they do is they just take like pictures from 120,000 feet from balloons, and then stitched it together to create like a flat map, and then like wrapped it around a ball. Oh wait. So the images from Earth of Earth from space are fake, and Rob Simmons also said that you wouldn't even see the Earth as a ball.
You
From
know that it's more
you would
than
need to be like
just
a million miles away.
it's more than one singular person that believes that has gotten imagery of the Earth, right? So if Rob Simmons says A, there's still a lot of other people that have left the Earth and been able to take photos, videos of themselves in the ISS.
Right.
So
Sure. Well, you know, like Richard Branson and Jeff Bezos, those
yes,
parabolic flights they did.
yes, I know them.
Yeah, yeah. Well, even Neil deGrasse Tyson will say that those flights that went up 63 miles up, you can't see any curvature from those flights. So, and when you're talking about the ISS, I can show you evidence of the ISS being completely faked.
Okay, so give me a second. Let's start to think about this. So, if you're close enough to something, there is a chance that you may not be able to see the full geometry of it. I put these speakers right up to my face like this, and if I'm this close, it just looks flat. But the further you get out, then you can understand more of the geometry of the thing that you're looking at. So, since the ISS is still within Earth's gravitational orbit, it must be still a certain distance away from the Earth from which gravity is still able to have its hold on it, and it could be too close to the Earth for a curvature to be seen, whereas let's say something like a Mars rover looking at Earth would be able to see curvature. So, do you understand that concept as to why somebody could potentially not see the Earth's full geometry due to the proximity?
Yeah. And that's what I was saying. Rob Simmons, the guy who made the blue marble, he was even saying that you can't even see the Earth as a ball, like with a black background of outer space, until you're like a million miles away.
Okay.
And he showed, yeah. So, but again, he's actually wrong though, because what Neil deGrasse Tyson says about you can't see any curve, it's actually incorrect, because even though like it doesn't matter how high you rise on a ball.
Okay, so I'm a little bit confused here as to
the ground.
It seems like you're picking
away from you.
It seems like you're picking and choosing
be curving away
things that you like about one person, because you say you trust Rob Simmons up until he says this, and then he's wrong now because this no longer aligns with what you're believing. Now I'm going to take from this other person, so I'm a little bit confused here.
I didn't say Rob Simmons is wrong. He's actually right. I'm just saying what Neil deGrasse Tyson's wrong about not seeing any curve at 63 miles up, like Richard Branson and Jeff Bezos, those parabolic flights they did.
Mm-hmm.
The reason why he's wrong is, and also the guy who jumped from space or not space, the Red Bull jump. If you rise on a ball, the ground away from you, like the horizon, would be curving away. So on a ball, the horizon doesn't rise up to eye level. So if you're at 120,000 feet, which there's like tons of amateur balloons going up 120,000 feet, you could see a level horizon for hundreds of miles from left to right. And
But this is
the Earth isn't a cylinder, right?
But once again, I said that this is very much due to perspective. Now, it could seem very flat for quite a while due to the size of it and how close you are to the surface in relation to the size of the general object itself. The geometry of it may not
Right.
come through to the observer properly up until you are a certain
Sure.
distance away. So if you
Right.
understand that's
But,
true, then why is there... Oh, I don't see a curvature as I'm leaving the surface. This isn't like Kerbal Space Program. Just because it looks like you'll see it as soon as you get out of orbit, or as soon as you get out of the outermost layer in Kerbal Space Program, that doesn't mean that's the way it actually works in real life. So why...
Yeah. But the in real life, like I could show you drone footage and stuff, but at 120,000 feet, people are showing a level horizon. At 120,000 feet, the Earth is way smaller, so you can see hundreds of miles. So you can see a level horizon.
Give me a
that's
moment.
literally like hundreds of miles.
Yeah, give me a moment. So I was designing a rocket that was going up to 100,000 feet. Excuse me. The 100,000 feet is literally just leaving the outermost layer, what we call the boundary between space and Earth. So just adding 20,000 more feet, considering that's 1/5 of what it took to get out, that doesn't seem to be enough distance away from the outermost layer of the atmosphere for you to still be able to get the geometry. So...
Sure. But all right. I mean, we could come back to this in a second, because anyways.
Well, I give me a moment. So
the horizon
you said that you want to get back to
rise.
it, but do you mean...
Yeah. The horizon, like if you're going up on a ball, the horizon doesn't rise to eye level. Yet the horizon's at eye level. At 100,000 feet, 120,000 feet,
I'm a little bit...
80,000 feet.
I'm a bit
Yeah, I know.
confused as to
It's
what
like
you mean by
yeah,
the horizon
So
is
if you
level. What do you mean?
Like the ground should be curving away. Like when you go up on a ball, when you rise on a ball, the ground that's furthest away from you is curving away. It's going down.
Once again sounds like perspective issue.
Right. And it's like it's the perspective. Like if an artist was to draw a flat plane, that's what the Earth looks like. Like if an artist was to draw a flat plane from being like really high up above it, that's what the Earth looks like from 120,000 feet, 100,000 feet, 80,000 feet.
But I have just stated 80,000 feet. You're still in Earth.
Yeah. But it doesn't matter.
Are you still there, Travis? Kind of cut out.
Yeah.
Oh, my bad.
Okay, there you are.
Okay. I'm sending a I'm sending a GIF to the chat right now. Hold on. This is a measurement at sea level. So the reason why I'm talking about high altitude stuff is like, oh, it looks this way or it doesn't look this way, and you can't really tell.
Sorry,
so
is the video...
in order to...
Is the latest video you just... Okay, no, it's one for 4 minutes ago. Never mind.
Yeah. So in order to tell if the surface of the Earth is curving away or not, you need to measure it. Do you agree with that?
To know if the Earth is curving or not, you need to measure it?
Yeah.
What do you mean?
Like to verify if the Earth is curving away, like the bodies of water, like the ocean. Like if, uh, in order to verify that if the Earth has any curvature, you just need to measure it. Like it's just a
But
geometry
this
problem.
isn't something
Like,
that
it's
you
basic
would
geometry.
this isn't something that you would measure as an observer. This would be something that you would need to do via instrumentation, perhaps kind of in I would assume this is something like advanced land surveying, where you try to make sure that I'm sure there's some type of optical instrumentation that you can use that would be able to measure this, but this wouldn't be something that you're doing via your own naked eye.
Yeah.
So
Right.
yeah.
The best things to measure the Earth, or to do long distance observations, are the Nikon P900 and P1000 because they have the best zoom lenses. So they increase the angular resolution.
No, I would not
the
be
most.
I would not be using pictures for this type of observation. This is something that you need to do via instrumentation, because there's a lot of things that you can do to make that even with our own faces, you can take pictures using lenses, and depending on exactly where you put the focal length, the perspective of what someone's face looks like can quite change. So using things that are essentially determined by purely naked eye, you use your eye to from there see how something looks, is not going to be properly scientific. I would never use a camera or my eyes or anything using my eyes to get these types of calculations. So if all of it is just based off of eyewitness observation, this is not legitimate.
Yeah. You're talking about measurements, right? So observing it is all you can really do, like observing the Earth. And if you want like laser measurements, I have that too. But this is stronger. Well, it's not stronger, but it's the thing I just sent. So based on the globe geometry, the horizon distance would change based on the observer height. So like if you're really low and close to sea level, the horizon's going to be closer.
Yeah, I
than if you're
remember
higher
you had
up.
sent this from before, from when we had first spoke, and this is the same issue as I just said. This is once again using a camera. A camera is not going to be a legitimate form of data taking for me.
Why
or
not?
Anyone, because cameras are with focal lenses, you can easily distort. You can make something look further away than it is. You can make something look closer away than it is. You can they're very.
What do you mean?
They're very non-precise, and it's very much just depending on whoever is taking the picture or the video to make sure that they've adjusted the focal length in a way in which is showing a legitimate picture of what's actually happening, because just based off a focal length, something can be very much distorted. And yes, this is
zooming in is an illusion. Is that what you're saying?
Zooming in is not an illusion, but if you have your focal length set incorrectly, once you zoom in, perspective can be very much skewed. This is not actual data measurement. If I told my professor,
but that's not.
But I'm just saying this is not something that is going to be held in any realm of science. If I told somebody that I know for sure,
it's an observation. So
an observation that's very qualitative, and that's not what we base things such as our entire physical systems around. We don't base it around qualitative measurements. That's not something that anyone's going to take seriously.
So zooming in isn't zooming in, or like what are you saying?
Is zooming in.
Okay.
Photo taking is not
when you zoom in on something, right?
Way of calculating anything. If I
Right, well, it's not a calculation. We're doing a measurement.
But
so when you zoom in on something,
is a measurement not a calculation?
No, it's not. It's a measurement. So when you zoom in,
no, excuse me. So
Yeah.
You need measurements to put something together. If I wanted to figure out what the volume is of a box, I would measure one side by one side by one side, and from there I would use those measurements to arrive at the volume. These things go hand in hand. And if you're taking a measurement, you cannot take measurements using strictly your observational abilities. If I got a box and I said, I think the volume is 1 liter, and I think that because I think this looks like roughly, 100 centimeters, that's not a legitimate way for me to take measurements. I can't just look at something and say I think it is because it looks like about. That doesn't work.
Yeah, that's not what I'm saying. Like the distance is like very important, and the height above sea level is very important in these measurements. So what I just sent you, these platforms, these oil platforms, are the distance. They're there to mark distance, and you can find the distance on Google Maps. They're just the platform hill house, platform habitat, and they're the furthest one's about 9 miles from, over 9 miles from the beach where this guy's taking this observation, which is he's just measuring the horizon distance.
Okay, so in this photo, how much
Yeah.
in your worldview would you expect the one that's further away to have dipped?
Right. Well, this is the whole point. At 1 foot observer height, based on the globe geometry, the horizon can only be 1 foot, or excuse me, at 1 foot observer height, the horizon can only be 1 mile away, 1.2 miles. Yet in this measurement right here, the horizon's 10 miles away behind both the oil rigs, even though it should be in front of both, like way in front, at like 1 mile away.
So
Yet it's behind both at 10.
I apologize. So you believe the human eye should only be able to see 1 mile away before everything should fade out, due to curvature?
Well, that's the globe claim. The globe claim is at 1 foot observer height, the horizon can only be at 1.2 miles away. So the geometric obstruction.
I have to know, like, once again, the every horizon distance measurement must be no more. So can I know more about the horizon should no longer be visible? Why is that? Is it because by what amount of angular dip has there been after 1 mile? Because if it's been 0.1 degree angular dip, I think you should still be able to see it. So how much does it need to dip in, or like how much does it need to curve? By how many degrees must the planet curve before you can no longer see the horizon? Because that's, if you're just saying it's 1.2,
well,
why is it 1.2?
Yeah.
Why isn't it 2.5?
Exactly. Well, it comes back to the radius, which this is the whole point of it. It's debunking the radius. But you're laying at the...
it's related to the radius. What I'm asking is, as a result of the radius, what is the amount of curve does there need to be? Because I'm based off of this, it seems like the curve would be very minimal.
Exactly. The amount of curve wouldn't change. That's the whole point. The ball doesn't inflate and deflate. So when you're really close to sea level, like when you're laying down, the horizon's going to be closer.
I don't understand what you just said. You said the ball doesn't
the curvature rate, like the geometry, right? The geometry of the globe doesn't change. So if the Earth is a globe,
doesn't change, but it takes a certain amount of time before you transverse 360 degrees to get back to your original position. But at 1 mile out, how much of a degree have you been able to? How many change in degrees has there been at 1 mile?
Well, that's the whole point. It's like if you're super low to the ground.
Yes, sea level.
Right. The horizon's going to be closer. So if you're high up,
that makes sense.
Yeah. And if you're high up, then the horizon, it doesn't matter about the amount of drop. What matters is the height above sea level.
But at sea
because
level,
if you're really high up, then it doesn't matter because the horizon's going to be farther away. So it's not about the amount of drop.
What is the amount of degrees that you end up having a change in? And why is it that specific amount of degrees that causes you to no longer be able to see the horizon?
Because that's where the like physical obstruction of the Earth curving away would like begin to block your view. So
But what amount
this is
is
just
that? I
the
mean, it's just
this
like,
is just the
does it change?
yeah.
If I'm at 2 degrees difference, is that why I can't see it? Does it start as this the second there is any form of degrees difference? May it be what do you call it, delta like delta D, so the change in displacement or
Yeah.
the change in curve, as long as there is an infinitesimal amount of curve, that's the second I won't be able to see it. I just don't understand your system, and I don't know why you have chosen the arbitrary number of 1.22 miles.
Well, that's the globe claim. That's not my claim. Like here, I have a
So
an Earth curve calculator
you should
link.
be able to explain the Earth claim if it's something that you don't believe in. Why have they chosen this number? I don't know what's special about 1.22.
Exactly.
Because,
Why did they? Yeah.
but who did you
That's the
hear
whole
this
point.
from? Is it just the video? This picture says it's 1.22 degree, 1.22 miles, and since you can see past that, you say, "Oh yes, the Earth must be flat." Or did you go and calculate this yourself to see at what point should it no longer exist? Because
Yeah.
when
Yeah.
I
This is just
speak to
this is
you,
just the I linked to a Earth curve calculator, and I listed like different horizon distances based on observer height. So at 1 foot it's 1.2. At 6 feet it's 3 miles away. 8 feet it's 3.6 or 3.4. That's just the globe claim. But as you can see, the horizon's 10 miles away, and I'll link another one that's 3 times farther. But as you can see, there is no curvature at all, and that's like 10 times falsifying the radius. It's falsifying it back 10 times because it's 10 times horizon distance. So, and this one I just linked is 3 times farther. So yeah, that's basically like game over for curvature. I mean, if you want like laser measurements, I have laser measurements done with a specially built laser that was done by like they did these field engineers did a series of laser measurements over bodies of water.
could you give me a
with,
moment? I'm just looking at this calculator that you sent
Yeah.
because
Yeah.
because you just gave like me a bunch of like calculations that you had put into there, but I don't understand exactly this calculator that you put in. The equations that they have here look fine, but yeah, I'm quite just generally confused as to what exactly you're getting at, because for your particular one that you said, so the distance to our object was what, 10 miles? Eyesight
Yeah.
level, I don't understand what, I will just put 1.
Yeah.
So according to this thing, the obstructed object, the amount that you should not be able to see is 12 meters with that amount of distance. 12 meters on something of that height is not particularly significant. So
Right. Because it's not about the rate of curve, it's about the horizon. So the apparent position where the sky is touching the ground should be in front of the oil rigs. But it's behind. Meaning it's the oil rigs are in front of curvature. Because the claim is that the horizon is curvature.
Yeah, but how I
So.
think you may be misunderstanding what the horizon point is, because just because you can still see the object doesn't mean that the distance to horizon is like, just it doesn't mean that a horizon isn't in front of it. Just because you can still see the oil rig doesn't mean that the horizon is not actually where it is.
No, the horizon's like you could see the horizon behind both of them. Like if the horizon was in front, then you would be able to see the oil rigs, but they would be like behind like curvature basically. So they would be like obstructed. Like you'd be able to see them because they're like taller, or they would be like sticking out, but there would be like curve in front of them. basically.
No,
I mean,
but
if you want, I have
no, but
I have
that's
like
not
yeah.
from the exact thing that you sent me. That's not the case. You would not actually end up looking curved. Would essentially just look partially obstructed. So I don't.
Right, but that's the curvature though. But it's not obstructed because the horizon's behind. Like when people say boats go over the curve of the Earth, they say it goes over the horizon. Um, the horizon is just the apparent position where the sky is touching the ground. So in this observation right here, the horizon's behind both the oil rigs. Yet it should be way in front of them. And there's also this one I just sent that's 3 times farther. But you know, if you want, I have laser measurements done by field engineers with like a specially built laser. That was like $60,000. It's like super powerful, and they calculate the refractive index and the max amount of refraction and everything. And they do a series of
Where
6 or
does
7 measurements.
why does refractive index come into place when you're trying to figure out Earth curvature?
Right. Well, if you're shooting a laser beam, the laser beam can like move based on the ambient conditions.
Yes.
Yeah, because of refraction. So, basically, these people they did a series of 6 or 7 laser measurements over a body of water, like 10 miles, 11 miles, 20 miles, where they would basically shoot a laser from like 3 feet above sea level, and it would hit the target like 20 miles away, 3 feet above sea level, and they would calculate the max amount of refractive index, and they found that every single time the Earth had no curvature. And
refractive
the
index
measurements
and
didn't conform.
curvature are not related to each other.
Okay.
Do you know what refractive index is? Because yeah, they are
it's the
related
amount.
to optics, but you would not be calculating.
Right. Well, it can change the like where the laser beam is. I mean,
Sure, yeah, it'll affect where the laser beam ends up being if, let's say, it's going
right.
through water. Sure, but that would not if it's something that's calculating the refractive index. These are not related.
Okay. But they found that none of the measurements conform to the globe geometry at all.
I'm a little bit
and that
confused
it was flat.
here because you will say, okay, as in, yes, refractive index is not related, and then you'll continue with your point. But if I just told you that refractive index is not related to trying to figure out the Earth geometry, then your point's invalid now because these are not related.
Do lasers refract in the air?
Yeah, if let's say the air is in balmy conditions, the water particles will cause issues. Yes.
Okay, so there's different refractive index based on the ambient conditions, right?
Yes.
Okay, so if you're doing a measurement over a body of water, then you would calculate the refraction for that with the laser, like if you're shooting a laser. And these people, they shot a laser basically from 3 feet above sea level, 20 miles away, hits a target 3 feet above sea level. So there's 20 miles of a level laser. And based on the globe geometry, that laser should be about almost 300 feet in the air because there should be a 300 feet of drop. So, yeah. But it's not. It's just level. I could send that if you want.
But,
and I could send a bunch of laser measurements.
Why would the laser end up curving to the Earth's geometry? If you shot it at a certain angle, it's going to perpetually go at that angle unless something's obstructed it.
Yeah, it's going to go straight.
Yes.
Right. So these people, they have a level laser over a body of water for 20 miles. Yet there should be 300 feet of drop for that distance. But it's not. It's hitting a target at...
Is there a receiving, receptacle on the other end? I'm confused as
to... Yeah. It's basically just, they're calculating the height that it's shot from, and then the height that it hits the target at above sea level. And it's like 3 feet above sea level. It's like the same distance. So
do you have something for basically this?
Yeah. I have a bunch of laser measurements.
Now I'm trying to kind of figure out where do you want to go here. Because essentially
Sure.
what
Well,
we're
yeah.
doing is you're saying, like, you're telling me something. I disagree. You move on. That doesn't, like, that's not a proper conversation because, like, what
You
exactly?
wait. What do you mean you disagree?
No, like, you'll tell me, like, oh, this does this, and I'll say, no, that's not what that should actually be, or, no, the drop is not significant enough for it to matter, etc. And then, you just move on. Hey, mods, can we please ban this person? Thank you. Yeah. So I just don't. Yeah, I don't know what we're doing here because if you're just gonna like, oh, I saw this thing. Oh, I see your thing. I disagree. Okay, well then I saw this other thing. Like, these aren't arguments. These are like you're like asking me to
So
essentially verify your studies for you, and like I don't know, I'm not really
right.
getting paid to look over your homework, so yeah.
So if there's a level laser beam 20 miles over a body of water, and it's shot from 3 feet above sea level and hitting a target at 3 feet above sea level, 20 miles away, what part of that do you disagree with?
I well, on paper, there shouldn't be anything I disagree with, but now it takes me always a second to look over your things. This isn't something that you had given me ahead of time. So, I mean, sure, on paper, that sounds like that has an issue, but perhaps I look further into the thing on my own time and I see that's different. But I guess that's a bit of the issue is, I mean, if I told you right now that I don't believe that the speed of light is exactly what it is because, there was some type of experiment that was run and for some reason it went 1.5 C, you'd be like, obviously, another physicist would be like, that's impossible. The speed of light is the speed of light. And I'll say, nope, I've seen a study that says this. And the person's like, well, yeah, if that's true, then that causes a breakdown. But who's to say what you're saying is true?
Right.
So,
Well, I'm sending you the measurements. I mean, it's all there. Like you can. I sent you the oh wait, I actually didn't send that. The Guinness World Record for long distance photography. But here's all the here's um like over 11 measurements, laser
also,
measurements.
okay, now, do you understand partially why I might have a problem with trying to, verify some of your stuff if it's coming from a YouTube channel called Taboo Conspiracy?
No. What do you mean? Like this thing I sent above that, the greatest laser experiment in history.
Okay,
That's
so
done by
I could take a moment to look that over, like, and then
yeah.
get back to you, but I
Well,
am going
yeah,
to be naturally hesitant to try to
sure.
engage with somebody whose YouTube channel has the word conspiracy in it.
All right.
Okay.
But the one I sent above that, which they did a series of measurements, that's done by a bunch of field engineers, field engineer corps. I would just read the PDF. It's faster than the video if you want. But
Okay. So, are you intentionally looking out for things that are confirming your worldview?
Well, this is what's the thing about this. Like, these type of measurements and all this stuff, like all these long distance observations, like there's literally tons. Like, this is all stuff that's verifiable and anybody can go out and test. Yet the globe proof, the quote globe proof, is a bunch of unverifiable information from a government agency. So this stuff we can actually go and test. Like we can actually test and measure the surface of Earth.
So, have you
But
not seen there being examples of, like, let's say Netflix documentaries where flat earthers will all gather together to try to prove that the Earth is flat? They run their tests and they see that.
sure,
So
you're talking about you're talking about I just saw some of that. I just got so pissed off today because I was looking at it. Basically, all that stuff is literally disinformation. Like, I'll send you something right now. That's
So
it literally pisses me off so much.
why do you consider
Look at this.
that
Look at
to
this.
be misinformation but not your information?
Right. Well, the reason why, and I'm going to send you a clip right now of Brian Cox addressing the flat Earth when actually he's not addressing flat Earth, and nobody in the mainstream, anything you see on Netflix or anything that's recommended to you on YouTube about flat Earth, debunked, like all this, like Professor Dave.
You still there, Travis? Cut out again.
Cox. I've been a flat earther for years. I know hundreds of flat earthers. Brian Cox right here, he says, he's talking about flat earth. He goes, flat earthers, they make an interesting claim. They say that the ground is actually accelerating upward, and this is what creates gravity. Not a single flat earther says that. Not one. That's a smoking gun. This guy's an actor with a TV show. So all these people who think that, you know, science is something that only people with TV shows can do, they address straw mans and don't actually address any of the real flat earth arguments. They address nonsense like the Flat Earth Society, which is controlled opposition. So they don't address any of the real arguments. Like all the flat earth debunked, anything you've seen on flat earth debunked is BS. Like there's a guy, Professor Dave, does like a video series debunking flat earth. Everything he says is bullshit. So this is what people think. They think, oh, I just debunked flat earth. These dumb flat earthers, when they're not even addressing any of the real claims. They don't even know what they're talking about.
So I'm a
they
little
won't,
bit
They won't
confused.
debate any real flat earthers.
Okay, so here, I'm debating a real flat earther. What is your claim
you are.
that, what is something that you have beyond, videographic things? Because I apologize, videographic just is not. This is a conversation that we had before. Do you have any peer-reviewed data? Because I remember before you had some guy that you said had smashed and destroyed quantum, etc. And that person was not a scientist. I looked into them further. Not really a person.
Well, what makes somebody a scientist? Is it having a TV show?
No, I would.
Okay.
I'm kidding.
Yeah,
you think I
I'm
consider
kidding.
Bill Nye
But
to be
what makes somebody a scientist, though?
Making somebody that is a scientist is someone that is or a proper scientist is someone that's respected within the field, is considered an expert within their field. For example, one of my good friends is a respected scientist within optical physics, and the reason why I consider her to be a scientist is she's gotten a PhD. She's been able to get some of her articles inside peer-reviewed journals. She has citations. People have used her studies to be able to build up on their own studies. She's been able to actually contribute to science, and use people have been able to build off of the things that she's done to be able to continue research within fiber optics, and that's why I consider her to be somebody that is a respected and qualified scientist. So, I mean, somebody.
Hey, this guy in your chat had the right answer. He said someone who uses the scientific method.
But I wouldn't consider just any fifth grader that's doing a science project that has the that's doing which ice cube shape will melt at the fastest rate, just because they had a hypothesis in this and this. That wouldn't be enough for me to consider them to be a scientist. I mean, sure, that's really cute, and I'm very, very proud of you for being a fifth grader doing a science project, but that's not someone I would listen to when it comes to their opinion on something science related. So my question is, do you have anyone that's respected, or that has been able to produce something that is...
Well, that doesn't right. Well, there's something called the Second Law of Thermodynamics, which I can show you a demonstration of entropy.
I have a degree. I know what the Second Law of Thermodynamics is.
Right. So high pressure moves to low spontaneously by itself. So
it's not entirely spontaneously. It's due to a particular purpose, but yes.
Okay, so with air in it, and I put the box.
You clipped for a second.
Can
you? Yeah.
Yeah. If I have a vacuum chamber, which generally, like the vacuum chambers people make are a lot weaker than what the
Travis, you might want to go work
A
on
vacuum.
you might want to work on your internet for a little bit because you're clipping a little
Okay,
bit.
give me a
it looks
second.
like
Give me a
it's
second.
cutting you out a little
Yeah,
bit.
no problem.
Oh yeah.
We'll give Travis a second here to see if he can fix that. How are you doing today, Kat?
I'm doing good. I am ready for my chugga choo-choo trip. It's gonna be a whole bunch of
I should
trains.
be good
Oh,
right
yeah.
now.
All right.
Okay, so if you take a vacuum chamber and you take a box with air in it and you put it in the vacuum chamber and then you poke a hole in the box, the air in the box will fill the vacuum chamber. That's high pressure moving to low. That's the second law of thermodynamics.
Thank you.
So, yeah. So, outer space is a violation of natural law. Like the vacuum of space touching the air we breathe, it's a violation of the second law of thermodynamics. It's impossible. It's fake.
Correct. That's why there are different types of mechanisms that are stopping the second law of thermodynamics of taking place in the way in which you're thinking. It's not just a purely empty boundary, and it's not like there's not something that's holding it together. But also, may I ask what the relevancy of this is? Do you want me to just confirm all of your different, like, science-based,
Well, what
your
this
science
means is,
system? Or, yeah.
what this means is, if there was a vacuum touching the air we breathe would fill the vacuum. So outer space doesn't exist. It's fake. It stands in violation of natural law, meaning it can't exist. So any sort of demonstration, like you can't demonstrate a vacuum touching gas pressure, or a vacuum touching gas pressure gradient without the gas filling the vacuum. So outer space is fake,
Okay,
provably.
so I always enjoy these tangents because they really make me think a few things, but is there a utility to why we're talking about this? Is this going to lead
Because
back
it's
into yes.
yeah, it's
what
one
is-
major claim of the heliocentric model.
Okay, and I remember
yeah,
okay, so I
it's fake.
remember your I remember heliocentric model conversation from last time. So once again, let's reconvene here. What are we talking about? Are we talking about flat Earth?
Talking about
Are we talking about
the cartoon
heliocentric model?
Right.
Are we talking
The
about
cartoon
both?
the cartoon that depicts the Earth as a ball moving around the sun. That's what people believe. And that cartoon depicts a gas pressure ball sitting in a vacuum, which is a violation of the second law of thermodynamics. So outer space, like it's fake. That cartoon is fake.
What is the relevancy of this to it being
Because
the possibility of this being a ball?
Because it completely destroys the globe model.
Why
like the whole globe cartoon is fake.
So why does the existence of outer space and the fact that our air doesn't leak out into outer space, why is this relevant to whether or not this Earth is flat or not? Because could we still not have the same system within a flat Earth if the system of having air and a vacuum can still apply to flat Earth? Then there's no reason why we need to go down this. So
it can't apply. Like
I think you're just
it doesn't
bringing
matter.
it up for fun. I think this is a tangent, and I love tangents. Mostly
No,
when I'm
it's one
on
of the-
listening to panels, but I don't understand why we're going here.
It's one of the main heliocentric claims that
But
the sky's a vacuum that you can
I don't
travel
care about heliocentricity because I'm not here to
Right.
debate heliocentricity. I am here to debate flat Earth. If you would like to
Yeah,
make
yeah.
it something that's
So-
about heliocentricity, then I'm going to
Well,
be
that-
here for 3 hours again like I was last time. And as cute as that was, I have other things to do with my life this time around. So
Right.
what are we
Well,
doing?
that's what it is, though. Like flat Earth is the lack of belief in the heliocentric cartoon. So the
But
people who believe
if-
the Earth as a ball
now,
going around the sun,
Let's reconvene again.
flat Earthers don't believe that.
Flat Earth, if a flat Earth could theoretically still be heliocentric, then I don't care about us talking about heliocentricity. It's either next time when you reach out to me, you can say, I would like to have an argument about all different types of physics, and I would like to tell you about why all physics is wrong, in which case I will clear off 12 hours of my day and sit here and argue with you for 12 hours. But if we're here to debate flat Earth, I do not care for heliocentricity. I don't care for your alternative physics systems. I want to talk about flat Earth and flat Earth solely. So which one will it be?
Right. So when you see the sun, for example, move in the sky, that's just because the sun moves in the sky. It's not because we're on a ball that's spinning around. That's the whole point. The whole entire like all the stuff in the sky, the reason why we perceive it moving and feel like we're not moving is because that's actually what's happening. The sun in the sky moves.
What is this need for flat earthers to be so interested in us being the center of everything ever, forever? Like, why must we be the center of the universe? Why must everything revolve around us? Why must we not move? Why must we be stationary? Is there a particular utility to everything revolving around us?
That's just what happens. I'm not interested in
but
utility as to why. That's just
why
that's just what happens.
is there a system out there that people have created in which we revolve around an entire different physical system than what's true? What is the utility for our society for someone to lie to me and say the Earth is revolving around something if it doesn't?
Right. So, like, why would they lie about that? Well, I'm going to send you some footage from the ISS right now. So, I have the same question. So, these GIFs I'm sending of footage from the ISS, I'm just wondering why they would lie. Like, when you see this, my question is, why would they lie about this? So, if you see the GIF I just posted, one of these astronauts basically manipulates a virtual reality like object that they pretend is there and manipulate it like it's floating around.
Okay.
So why would they lie about that?
Why do people do video editing?
No. Why do they use augmented reality to make pretend that they're manipulating objects in 0G?
Why do YouTubers sometimes have intros where suddenly they appear in their chair when they weren't there before? I don't know. Why do people display their ability to use modern day technology?
This isn't just random people though. This is footage from the ISS. This is astronauts that are supposedly floating in 0G. So why would they do that?
Wait, I'm just throwing in your stuff to give over to Twitch chat so that they can see it. One moment.
Yeah, there's like a ton of these clips. It's just a few.
Okay, so is it never possible that a potential utility could be, I don't know, to show off what they're currently working on, to add a certain level of awe and ooh to the videos? You know, perhaps someone might have it might be a educational video. They're talking about something and then they show like, look, we were able to do this, and everyone's like, wow, that's so real looking. I didn't know that the ESA currently is developing this kind of technology. I mean, why is there a conspiratorial tone to why is AR a thing?
Have you seen the movie Gravity?
I have skimmed through it. I haven't watched it in its entirety, but I've skimmed through it.
Do you know the parts where Sandra Bullock is like floating around in 0G?
Majority of the movie, no?
What?
That's majority of the movie, no?
Wait, what?
Is the movie not majoritively her just floating around?
Pretty much, yeah.
Okay.
Yeah, so do you know how they do that? like how they fake space for movies. They put them on wires.
Okay.
So just like this GIF where this astronaut getting tangled in the wires when he does a flip, with a guy like getting like he's like falling, but he like can't rebalance himself in the wires. That's what they're doing. They're using wires and augmented reality to pretend that they're in 0G.
I mean,
And
that's a lot
NASA is
cooler
actually
than
going to get.
that's a lot cooler than not doing that when you're making a space movie.
So why are they faking it though?
Why are actors not going into space? Because it takes a
No.
lot of training.
Why are the astronauts for NASA doing what people do for movies? Why aren't they just filming themselves in 0G legitimately?
Because the amount of training that you need to give to people, there might be some that are done there, but also
So they're not on the ISS.
I
So they're
don't
not
know.
on the ISS floating right
I
now.
don't know what this particular video that you sent me is. If you're talking about if that's an ISS based one, then that's not what I'm saying. But perhaps there are other types of videos where hyperbolic flights happening, or they might simulate a 0G environment just for, I don't know, just a random video, and the utility of that is look 0G. But
The GIF that he's referring to, Kat, is he put it in our private chat.
Okay,
Yeah.
the ones that then I don't know who these particular astronauts are, so I can't tell you if they actually are on the ISS or not. This is a random GIF. I can't.
Yeah.
Well,
you might recognize this last one I just put. You might recognize it's Don Pettit manipulating fake coffee, and it like glitches out of the cup.
Sorry, you're just giving me like a bunch of GIFs. I mean,
Yeah.
I personally would love to have every single astronaut memorized, but I do not.
Well, Don Pettit is the reason why so many people know him is because he's the astronaut who talked about the moon landings, and he said, "I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore." So we don't have the technology to go to the moon, even though we did it in the '60s.
I mean,
but it's too hard now.
It's super cool if somebody would love to go to the moon, but not everybody has the ability to go to the moon. That's not something that the average person, even the average NASA employee, is going to get to do. The amount of training that you need to do to be able to get to the moon is insane. The amount of medical tests that you need to pass to be able to get to the moon is insane. Very, 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 very few people will get to do it. And also,
you need to be a Freemason.
What?
You need to be a high-level Freemason, and you need to know about the lie, because all they're doing is faking it. It's all faked.
I'm sorry, what is a Freemason?
It's a secret society. It's basically
Okay.
There's like all the astronauts are Freemasons, like Buzz Aldrin, and Kyle Rittenhouse, Fauci. They're both Freemasons. Like there's a lot of celebrities, a lot of powerful people. They're all Freemasons. There's a sign they do. It's called the Hidden Hand. And
I'm sorry. What are you?
Well,
talking
anyways, they have a
about?
bunch of signs.
No.
There's a secret society.
What are you?
That,
what are we?
Yeah.
What are we talking
The Freemasons. About? It's like a secret society.
Where did we? How did we get here?
Well, in order to become an astronaut, people think, oh, you have to do all this hard training and it's really hard. Well, no. In actuality, all the astronauts are just Freemasons. They're not actually doing any training. They're not actually going up in space. They're not doing anything. They're faking it all in a studio. They're all actors.
Okay.
Like, yeah.
Are you like an adrenochrome person?
What do you mean?
Like, I'm confused as to like what level of like conspiracy are we getting to here? Like, are you like a QAnoner? Like, where are we going?
I mean, it's not really relevant to the space thing, because the space thing is like the highest level.
There's a lot of things that we're talking about here, so we might as well just get all the way in. Like, do you believe in 9/11? Like, what level of?
Well, we can't talk about that.
Why not? It's my
You're
channel.
Gonna get your channel deleted. Yeah.
It's my channel.
What do you mean?
I brought it up. If I have a problem talking about it, I wouldn't bring it up. Like.
Okay, so well, it's real simple. 9/11. Tower 7 wasn't hit by an airplane, and it collapsed at free fall speed. So that's it. That's it. Game over right there. The reason why
Don't all things fall at
yeah.
free fall speed?
No. In order for a building to fall at free fall speed, like a controlled demolition, all the supports need to be blown up at the same time. So the like a bunch of architects and engineers, because most people don't know about Tower 7. So there's a guy Richard Gage, and he sits down architects and engineers and shows them Tower 7. And most people don't know about it, so they don't even know. And he shows them it, and 100% of them say it's impossible. And 7 years after Tower 7, because it's on video, like 5 different angles of it collapsing at free fall speed. 7 years later, the government came out and said fires caused it. Office fires caused the building to collapse at free fall speed. So the reason why that's not on the news, a building being blown up blatantly, is because the people who did that control the TV. So the reason why Flat Earth is censored is because it's real. And the people who control the internet don't want people to wake up to the truth. So, yeah.
Okay, so I have a question. How do you operate as someone in the world basically not believing a single thing that is seen as factual because your physics system is off, your news system is off, like just
wait, what do you mean physics?
Just everything, like everything that you believe about the world is the polar opposite of what is accepted
mainstream,
as,
you mean?
I mean, as cool as it would say the mainstream, because it makes it kind of indie and kind of like edgy. Like, I'm not gonna give you that one. Like,
no, it's because the people who run the world control the TV. Like, I don't know if you know this, but
and then there's always the people for people. Who are you ever talking about? Who are you talking?
Well,
who's
again,
the people.
This is why all the astronauts are Freemasons. So, like I said, Rittenhouse, the whole Rittenhouse thing. By the way, this is how deep it is. And people think it's like, anyways, Kyle Rittenhouse, that whole thing was fake, all of it. There's literally a part of the trial where the prosecutor's walking up, and his foot glitches through the floor, and Kyle Rittenhouse does the most blatant hidden hand sign, which is a Freemason gesture that I've ever seen. Like the whole thing, and he was getting interviewed by Tucker Carlson, who works for the CIA. He's getting interviewed by Tucker Carlson, and he like missays the script. Like he literally sounds like an actor who got his lines wrong, and it's like bad. Like Kyle Rittenhouse, that whole thing, he's an actor. They're setting him up as like a character. The whole thing's fake.
Okay.
I could send you the thing where the prosecutor's foot glitches through the floor if you want to see that.
You know what? I'll pass for tonight.
All right.
But I'm just
Well, look, the Earth is actually flat. So I know it seems crazy.
Okay, so
but literally everybody believes the globe, and it's not real.
Okay,
so people literally believe they're spinning when they're not.
Okay, so let's see. Why can you convince me for a second? Why should I believe you, someone that has basically conceded to say that every single thing about the world that the most people
not
believe,
everything. Not
you
everything.
Don't believe.
Right. Well, because it's just true. Like it literally is just true. Like.
But what makes you qualified to consider anything to be true? What makes you the moral authority or intellectual authority on any of these things?
Like what specifically?
Anything. Why do you know about 9/11? Why do you know about
because it's on video.
Why do you know 9/11 about astronauts? Why do you believe that we can't have an atmosphere? Why do you believe that the Earth is flat? Why can't the world be heliocentric? There's like so many different things, and why are you the so smart person that has been able to unlock all of this?
Well, there's a bunch of us. I mean, I know it's probably because you don't exposed to this type of information, but because they control the information, so that's why. And like,
well,
look,
I mean, excuse me, I'm a socialist, which is very much not a very cool thing to be within the US. And I'm all forms of media basically tell me that that's the incorrect political leaning, economic leaning to be in. But I still find my way to find more out about that system. So it's not as if I just sit there drooling at my TV every day and just saying, yes, Anderson Cooper. So I just don't
I know, but
understand.
you're underestimating how advanced it is. So Hollywood, right? Every actor you see you should just assume they're in the CIA. Same thing with every single person you see on the mainstream news. It's all CIA. It's military. It's psychological operations. That's what it's all for. So people like, this is even Joe Rogan. Joe Rogan's a shill. Joe Rogan is literally a shill. Like, I could literally show you evidence that's just the most mind-blowing. Joe Rogan literally said he did this show called I forget what it was called, but he was like looking into conspiracy theories like Bigfoot and aliens and stuff. And there's a scene where he like looks at the camera. He's like, "Hey, CIA, I'm available. If you guys want to show me the real stuff, I'll lie to my mother. I'll make fun of that crap till the end of time." So he literally says, "Hey, government, I'm available. Hit me up."
Okay.
And what you see,
do you
hold
not
on.
see like a bunch of people that just typically make those kind of jokes? Like, yeah,
no.
consistently
Okay,
says he's a CIA
yes.
prop.
I know, but just at that, I wouldn't say, "Oh, he's a shill," because of that. But Joe Rogan's friend, Eddie Bravo, who's a conspiracy theorist, he's a flat earther. He has Eddie Bravo on when he has Alex Jones on, because Eddie Bravo is like, he's a better conspiracy, because Alex Jones is also a shill, but Eddie Bravo is a better conspiracy theorist than Alex Jones. Yet there's clips of Eddie Bravo bringing up flat Earth to Joe Rogan, bringing up simple shit, like super simple shit. And Joe Rogan is like playing dumb, lying, saying like, "Well, you don't even know what that means. Like, you didn't go to school for this stuff." Like, literally saying dumb shit like that. Like, playing dumb. And Alex Jones even said the same thing to him. He's like, "Joe always plays dumb. He always knows the conspiracy theories." Like, Joe Rogan is literally a shill. So is Alex Jones. They're covering up flat Earth. Anyways,
Okay.
let's just do the rotation of Earth, please.
Yeah,
Can we
so
do that?
that's what I want to say. Let's reel this
Okay.
in. But it's
Yeah, let's
good,
get back on topic.
but it's good to know where you stand. Okay, so rotation of Earth. What do you want to speak about?
So we don't
Wait,
feel
am
the
I
Earth move at all.
CIA?
No.
Why am I not CIA?
I don't know. You're just not. There's
You have
just
to tell
no.
us if you are, Kat.
Pardon?
Well, there's just
You have to tell
there's
us
just
if
no
you are,
evidence that you are.
As
There's
okay,
there's just no evidence that you are. Like, you haven't really done anything.
is there a sign I need to make to be CIA? Like if I do an OK sign, but like upside down, that makes me CIA?
No, it might make you a Freemason, but anyways.
Like okay.
Yeah.
Cool. Noted.
Ooh. Yeah, that means you drink baby blood or something.
Sick.
Well,
busted.
So-
Cat CIA.
yeah. So the rotation of the Earth, right? We don't perceive or feel the motion of the Earth at all. All we see are the objects in the sky, the celestial objects moving, and they move like clockwork. So if the Earth was actually rotating, there's something called the Coriolis Effect, which should exist if the Earth rotates. So what Neil deGrasse Tyson says, he said this in an interview, and he made a tweet saying, like a certain football team kicked a field goal, and it probably went in because the Earth rotated underneath the football. So do you agree with that? That if the Earth is a rotating ball, that the Earth will rotate underneath footballs and stuff?
The Earth rotates consistently, so the Earth would, in practice, rotate underneath footballs. It also, rotates under your actual testicle balls. It rotates under basketballs. Like, what's your point?
Well, it would be creating an apparent deflection. So, like, not just saying that the Earth just is moving even though it feels stationary. He's like Neil deGrasse Tyson is saying that when the football gets kicked up, the Earth actually moves underneath the football, and the football appears to deviate because of the Earth moving underneath the football. So, do you agree with that? That the Earth would move under footballs?
In a literal sense, it's rotating under footballs, but wouldn't cause a deflection. I don't think
So how do you know it's
understand-
moving?
I don't think you understand.
So
this
how do you know it's
fact.
rotating then?
Pardon?
How do you know it's rotating if there's no apparent deflection?
We know it's rotating
Coriolis.
via other methods. I know that this is not a
Like what?
system that you believe in, but perhaps the time of day. So depending on
Right.
what day it is, what time of day it is.
But we just see the sun move in the sky though. So how do you know that we're actually moving and the sun's not just moving like we perceive?
Why do we have a certain time in Montreal but a different time in Dubai?
Right. Well, time zones are just man-made. So, but again, all we perceive is just the sun moving.
No, hold on. We're gonna reel that back. Right now, if I go and call somebody that is in a different time zone, they would say that in the sky right now, the amount of sun I'm seeing is significantly different than the amount of sun that that you're seeing. So that's not man-made. Time zones, yes, they are man-made, but what we experience as a result of like what time it is, yes, someone has a different amount of sun than another person has amount of sun. So how do you explain that?
Yeah. Well, again, all we see is the sun moving in the sky. And if you're trying to say that the sun wouldn't set on a flat Earth,
that's not what I'm saying. What I'm saying is that if the Earth is a flat plane, then everyone should be experiencing the same time.
Well, no, because the sun is like small and local and lights up only a certain portion of the Earth at a time. So, and the sun actually moves in like a spiral over the course of a year, and it moves like a clock. So, like the celestial objects in the sky move like clockwork, and we just perceive the stuff in the sky moving. So we don't actually perceive any movement ourselves, and the Earth is supposed to be moving like 6 different directions.
Wait, didn't you say at some point that the reason why we have gravity is because we're a flat plane that's moving upwards?
No. The whole point was that no flat earthers actually say that.
No. Okay, no one does say that. So then how do you explain different things like gravity if you don't believe that the Earth is moving?
Well, gravity is claimed to be the bending and warping of space-time caused by mass. So
I mean, that's only within like a more recent worldview where we
relativity.
only think about the bending and warping when it comes to like massive objects, which really Earth doesn't really count as being one of those objects in which the bending and warping of time really comes to place. It's more of a black hole in like very dense.
Well, no. That's Einstein's relativity, which superseded Newton's gravity, which was saying mass attracts mass. Einstein's relativity says that mass causes the bending and warping of space-time, which is like a fabric, and that causes the downward vector.
Yes. Yeah, but that's not something that comes into place with something of our gravitational pull. Our gravitational pull is hardly enough to even redshift things. So cause gravitational lensing. So gravity, our bending of space and time is basically negligible because it's not a dense enough celestial object.
So we don't have gravity?
We have gravity, but we don't have... I have gravity, but also time doesn't warp around me.
Okay, so you don't have gravity then?
I do have a gravitational pull. It's not enough to be significant.
Well,
it's just like I have... due to de Broglie's wavelength, I have a wavelength, but it's not enough for it to matter to anybody.
Right. Well, gravity... I just sent you a link of the general relativity physics textbook.
You're gonna send me a textbook?
Well, it's just the definition of what gravity actually is. But gravity is claimed to be the bending and warping of space-time, yet if you're going to try to validate that using the scientific method, if you're going to try to validate that that's what causes the downward vector, like if I drop a pencil, you would need to manipulate the bending and warping of space-time as an independent variable, which can't be done in an experiment. Yeah, so like if I drop a pencil,
not
right?
all gravity, not all things with gravitational pulls are going to warp the space-time continuum. It needs to be a certain density. It has to have a certain gravitational pull. Even the sun is not massive
that's
enough.
That's what the definition of gravity is. It's the bending and warping of space-time. So if I drop a pencil and the pencil falls, and I'm going to try to verify that gravity is the cause of the pencil falling.
So now what? I disagree.
Well, I just sent you the source, the physics hypertext book, saying that gravity is the bending and warping of space-time. So that's what the current gravity, which, that's what the current gravity definition actually is. So, but if I'm going to try to validate, if gravity is what's causing the downward vector, like if I drop a pencil, I need to manipulate that bending and warping of space-time to validate that that's what's causing the downward vector.
We don't need to. It wasn't until afterwards that we needed the additional definition from Einstein, because with using things of the mass that we had access to prior to the 20th century, it was enough to just think of it from a classical perspective, in which it's just related to the Newton's law of gravitational pull, which is a mass and another mass are able to
the whole point
together. And
the whole point is that you can't manipulate gravity as an independent variable in an experiment. Meaning you can't validate it using the scientific method. So gravity, by definition, is actually pseudoscience.
What?
It's the same as me saying, like, if I drop a pencil, I could just say, oh, unicorns is why that pencil falls. It's literally the same exact thing. So this whole bending and warping of time, it's like a concept. You can't actually manipulate it or validate any of it using the scientific method. So
yes,
by definition,
you can,
it's not science.
We know about gravitational lensing. We know that a light that is coming from a certain planet is able to be bended towards us, in which we can have something look like it's coming from a certain source, which it's not.
How do you verify that?
Pardon?
How do you verify that?
How do you verify gravitational lensing?
Yeah.
I actually am not going to even try to make anything up. I know that this is something that we use. I'm not sure how they verify it, but
so the reason why why they're saying that,
saying I don't know how they verify it does not mean that they do not verify it.
Okay, but you don't know how they verify it, though.
Yes, but you don't know how they verify it either. So now we're at
right, but they can't, though. That's kind of the whole point. And like if I go out and I observe these lights in the sky, you can't really verify anything about them. You can't really test them. So like what they say, the reason why they say that, what you're saying about gravitational lensing, is because the lights in the sky actually completely debunk what the globe model says. Like, for example, nighttime on the globe is when you're facing away from the sun. So when the Earth turns, that's why the sun rises, according to the globe. It's because the Earth is actually spinning.
Yes.
Not because the sun's just moving. Yeah. So when you're facing away from the sun, you're looking away from the sun, that's nighttime. So every 6 months, you would be, looking away. Like at night, you'd be looking away from the sun, looking at a whole other part of the galaxy. But the order of the solar system is the sun, then Mercury, then Venus, and then Earth. Yet at nighttime, when you're looking away from the sun, people can see Mercury and Venus at midnight, even though Mercury and Venus are between the Earth and the sun. But you can see them at nighttime, which is looking away from the sun. Also, the Earth would be moving in 6 different directions.
No, I'm sorry.
Yeah.
Can you explain as to, just because it's the sun, Mercury, Sun, Mercury, Venus, and if you can't see the
Earth.
sun, you can still see Mercury and Venus. Why would that be counterintuitive to what you're able?
Okay, because the Mercury and Venus are in between the Earth and the sun.
Mm-hmm.
So when you're looking away from the sun, that's night. So at night,
Yes,
you're
but
not looking towards the
they
sun.
could be at a different point in their orbit, in which is still being able
In
to
between, yeah, it would still be in between the Earth and the sun.
Yes.
So at night,
let's say
you're looking away from the sun. Yeah.
Can you see me? I'm not sure if you're
Yeah.
Okay, so let's say you have, Earth is here in its trajectory, and obviously if Mercury and Venus were here, you couldn't be facing this way, and in that case it would not be possible. But if the Earth is here in its orbit, Mercury's over here in its orbit, you're able to look at it in a way in which you're still able to miss the sun because you're at a certain angle. That's why you can only see it during certain times of the year, and you can't see it all the times of the year because it really just depends on our relationship in terms of how are they set up.
Right. That's what people say, which is also what they say about the Selenilian eclipse, which doesn't work. It's the same thing. They're just saying that. Yeah.
I'm kerfuffled because this is like a thing that you typically do. So you say it's not possible. I tell you it is due to an alternative explanation, and you say that's what they say. That's not really an argument, is it? Is like people do.
Well,
say
I mean,
that.
I wasn't done talking. I was just So, it's actually not possible because you can see it at midnight.
Mm-hmm.
So it actually doesn't work. But what they say is
why is the fact that it's midnight the thing that checkmates?
Because you're looking away from the sun. So even if like they're in some crazy orbit, like on the side or whatever, it's still you're not gonna be able to see it because it's still in between the Earth and the sun. Like you still wouldn't be able to see Mercury. But you can.
Are you just saying it's at midnight because perhaps it happens at 8 p.m.? Are you just saying?
Well, you can see it at a bunch of different times. But yeah, you can see it at midnight.
There's certain stars.
I mean, I've seen Venus myself.
Congrats. Yeah. But there's certain times in which you're able to see some stars, and sometimes where you're not able to see other stars. Also, I have somebody here that just dropped something from the National Radio Astronomy Observatory, and it says that that's not true, that you can see Venus at midnight. It's just before sunrise or just after sunset. So.
Oh, okay. Well, I actually have the video of it at midnight.
Do you have do you own like a radio telescope? Why is it that you can see it specifically at midnight? Why do you know it's exactly Venus? Somebody just timestamped it? Did you personally take this photo? How do you know that you had the right planet?
Yeah, I mean, you're just saying like basically that's like my argument was what you're saying, but you're just doing it to the like it's kind of I don't know, it's just kind of weird. Hold on.
Is that your argument that it's kind of weird?
No, what you're doing is like the ultimate skeptic. Like you're just like, oh, well, how do you know that though?
Because everything that you give me always happens to be a GIF or somebody's video or a YouTube video from something called Conspiracy Thought or something. Whereas
right,
or
a series of laser measurements done by field engineers,
which I have
not PDF,
which I have not been able to say anything about because I haven't looked at it, and that wasn't some information that you gave me prior.
I mean, unfortunately, you could just click on the PDF and like scroll down to. I
can't read a proper PDF during a conversation unless you would like a 10-minute lapse in voice. But I can do exactly what I did with you last time, where you told me about some person that destroyed all the theories, and I looked back afterwards, and now I'm able to tell you that that person was wrong. But I can't tell you, anything about the document that you're sending to me in the middle of this conversation. But somebody says, where's the study? So I can definitely give it to you guys, chat.
I'll post it in there. I've got it up right now.
Thank you.
What are you talking about?
The laser one.
Oh, right. Yeah. So basically, everything about the stars is unverifiable. So, like, if you go out and you look at them, um, that's just like step one of the process, observing these lights. It's like, what is step two?
Pardon?
So if I go out and I look at these lights in the sky, that's
Yes.
step one. I observe these lights. I observe these celestial bodies.
Okay.
What is step two?
I'm sorry, what are you asking me? I don't. You go outside
So
and
how
look?
do you about verifying anything about these lights in the sky? Because you can't. All you can do is observe them. So we're just observing these lights, and we can't really test anything about them.
You can't. People that are qualified can. Just like
How do they do that?
People that actually are qualified have proper instrumentation to be able to properly look at these planets. So looking at Venus and not just looking and saying that looks kind of like it could be, the color looks like Venus. Instead, they're actually able to look properly and confirm that this is the same body that
Observing. They're just observing it.
they're
So that's
observing,
what I
but
can do.
from something
I can do that too.
but you don't have the same instrumentation. You have,
Well,
I don't know,
a telescope. I mean,
but do you have what is your telescope? Is it a telescope that is powerful enough to properly verify?
again, it's still just observing the lights. Even if you have a better telescope or a worse telescope, it's still just looking
Okay,
at lights.
do you want to know what else is just observation? So somebody that's trying to figure out whether or not somebody's speeding, I can just look at a car and say, that looks like that's going faster than what the speed limit is, but somebody with the proper instrumentation can actually say, yes, they're going exactly this amount past the speed limit. One is able to say, kinda, like, it looks faster, and one is able to verify that it's faster. At the end of the day, there's no divine power that's telling them anything. They're going to have to see what the measurement is with their eyes, but one is quantitatively able to tell me some things. One's able to say, that's the difference.
Okay, but you can't do that with the stars, though. Like, you can shoot a radar
But-
gun at a car and like,
But
get
you
the speed.
can do it with the stars
but you-
because no, it's not. The same as they can't walk up to it, but they might be able to see that it has a lot of the same features as what they said was Venus the day before. Does it have the same physical characteristics? With the telescope that we have, does it have the same gaseous composition? Is it exactly in the same place calculatably as it should be at this time of day? Okay, well, due to all of these things, I know for sure this is Venus, whereas you, with your Walmart telescope, is like, yep, that looks like Venus.
Okay, so you can observe lights in the sky and then assert that it's the same thing as the ground that you're standing on, and it's in a sky vacuum. That's basically what you're saying.
Sorry, what?
So you can observe lights in the sky and then assert that it's like a rock in a vacuum and that the Earth is similar to these lights, even though it has no similar characteristics at all.
What are you talking about? Like,
yeah,
I'm
so
looking at Mercury
people assume,
and
people assume that if they see a planet, that the Earth is a planet because they obviously share so much in common, right?
that's not how people determine what the shape of our Earth is. It wasn't just, what do you call it? Like, the law of thermodynamics where if A is similar to B and B is similar to C, then A and C must be the same thing. That's not how we determined what.
No, they look at lights and say that it's the same as like Earth. They say that it's the same as like a planet. You know, they assert that it's like basically either a rock or gas within a vacuum, like a ball. Even though you can only see a circle, they assert that it's spherical and it's in a vacuum doing like this orbit that, you know. So you can't really verify any of that stuff. And the medium that it's claimed
so we
to be in.
We use our telescopes to see that this planet are made out of hydrogen and sodium. This planet's made out of helium and potassium. This
Yeah, but that's
planet's made
just
out of this and this. That we don't just assume because all these other things are
uh,
made out of this that we must be made out of the same thing. That's not.
no, no, no. But that's an assumption. Like you can't just look at a light in the sky and then say, "Oh, this is made of this," without actually going there and testing it.
Yes, you can.
That's an
It's
assumption.
called spectroscopy.
So because it's a certain color, you know what it is.
Because of the type of light that it's giving off, you can know that it must be this due to the absorption or reflection spectrum. Yeah, that's the way that we figure out things all the time. I mean, it's something that you do in a
Okay,
first year physics lab is you look at the lines
right.
coming out of a certain light bulb, and because there's two yellow lines, you know that it must be sodium.
Okay, so the medium that these lights are supposedly in is a vacuum, which is a violation of the second law of thermodynamics. So it can't, like that whole story of these lights, which are rocks in a vacuum, the whole thing is fake because the medium that they're in is fake.
So
And
everything's just nothing. Like when I'm looking over at Venus, actually, what is it then? There's no gas in
exactly,
there. What are
that's the question
I'm
because
asking
you
you?
can't.
No,
I know,
because
yeah,
I always have to I have to always back up things. What is it made out of?
right. Well, you can't have, we have gas pressure on Earth. You can have gas pressure without a container. Yet these lights are supposedly
That's not what I
in a
asked. What's Venus made out of?
right, right. So it's not made out of, like these lights in the sky are not what NASA's depicting.
Okay, but what
And
is it made out of?
right. Well, it's just a light. It's
Yeah, it's
not.
just randomly being
It's not a
produced.
rock in a vacuum.
It's just randomly
Well,
being produced.
they're lights that move like clockwork, and they
So
move in a
what?
yearly path. The
What's
the
there's
stars move in
just
a
like
yearly.
a cell phone flashlight?
Well, they're put there by the person who created the Earth.
That's great. So what is it made out of?
Uh, I don't know. No one knows.
No one.
But
So
it's just a light. So
so
like
why
yeah.
is a random rock producing light?
Well, it's not a rock. It's not a rock in a
Okay,
vacuum.
so then what's Venus?
It's a light in the sky. It's a
So
light
if
that's
I
like
have a
nailed
vacuum,
on.
if I have a telescope that's powerful enough for me to see the surface, then my telescope's lying to me.
To see what?
If I'm able to see like surface, like let's say if I have a telescope that's good enough that I could see, you know, the a bit of the surface of the Mars, is it just my telescope's lying to me?
No. Like you
So
could see the lights. I don't like. What do you mean?
no, but like I see that it's actually like there's a surface to it, so it's not just the random light. It's if I people do have
Well, you don't
telescopes
know
that are
what it is
powerful.
though.
Oh,
Yeah, you're just looking at a light. So
but if
you
I
could
can,
say like, oh, it
but
has a surface,
since
but that's just because
why
that's just an assumption you're
since
making.
when do lights have surfaces? If I go to I don't know if I go to an observatory, which a lot of places have, you can go to observatories, and observatories have pretty good telescopes, and you'll be able to see at least that far. So if I go to an observatory and I can see Mars and I can see the surface, which I know it's a surface because there's texture to it. What is it?
Well, it's just a light
It's
though,
a textured
so you
light.
don't actually know what it is. You're just asserting that there's
There,
like this surface to it.
there's a
So,
textured light. You've seen lights that are textured. You've seen flashlights that have texture to it.
uh, uh, what do you mean?
If I
Like,
can see
if
the
you
surface, if I can see
have you
it,
actually looked at these lights through a telescope?
yes, I've gone to many observatories. Every time I go to any city, I go to an
Right.
observatory.
Yeah. So it's like a circle, and it's a light. So
Yes,
what do you
but
mean?
observatories often have telescopes that are good enough that it's not just I'm seeing random light. I'm able to see like at least a bit of the surface of the thing. What am I looking at?
Well, again, whatever. Like it can't be in this medium of a sky vacuum. So you're literally looking at lights that are probably like on the
Why does it have
container
texture?
of our
Why does it have
Earth.
texture?
Well, we don't know what they are. So
So it's just a textured light. It's like, I don't know, like a light
nobody
that's
knows what the
organized
lights
in
in
a
the sky
special
are.
way.
Well, the Bible says they're watchers.
Why do I care about
like
the
the
Bible?
planets. Well, this is just what the Bible
Why do
says,
I
which
care?
the Bible's
But
more
that's not,
accurate.
no,
Well, the
no,
Bible's more
no,
accurate than
no, no. Why do I care? Because that's not my religion. If I told you right now I'm Hindu, I don't give a fuck what the Bible says. Why do I care?
Well, it's not necessarily my religion either. But
So
I'm just
then
telling
why
you
are
what
we
it
bringing
like
it up? Why are we
because
bringing up any religious documents? I can also tell you that the reason why I passed the test is because I sang Om Ganesha enough, and Ganesha is the god of prosperity, but that's not relevant to this conversation.
right. Well, the whole point is we don't know what they are. Like no one knows what the lights in the sky are.
But there are
I don't like
people,
no,
like, as I just said,
like
there's
nobody knows.
have you, once again, spectroscopy. So there, due to the color of light that is being emitted, there are emission and absorption spectrums, and as a result of the type of color of light, and if it aligns properly with this, we know what the makeup is of that planet. It can't just be light. Yes, light, the different types of elements are able to produce light. Yes, if you put a certain amount of energy onto an atom, due to what type of atom it is, it will give a certain amount of light back. As I said, sodium gives yellow, and that's how we know, okay, if the light coming from this star is a certain type of yellow, it seems like it must be a sodium-based planet. So this is why we know it's not just a vacuumous random light. There's actual chemical composition there. So what's the issue now? Why, like, there are telescopes that are good enough for me to see surfaces. That's why we're able to do things such as mimic what the Mars might look like. Mars looks like for movies, because we know what Mars's surface looks like, so we're able to create
You
environments.
lost him.
Oh
You've upset him. I'm just
no.
kidding. He had the same thing happened earlier before
Mhm.
you guys started, so we'll give him a see
Yeah, sounds good.
if he pops back in. But how you doing?
Yeah.
This is fun. Also, how long did you guys want to go? Do you want me to give you a hard stop at some point, or just let you go until you tire each other out?
You don't know, because I am not tireable. And I don't think he's particularly tireable, but I don't think anyone wants to sit here and listen to this until bed happens 5 times over.
I
Chat.
mean, I'm ready for it.
Okay. Chat, how you guys feeling? Just as a reminder, this is my current job. So if any of you would like to, pop a dono, a sub, any of the things that I can use to, I don't know, go see a doctor after this, please do that.